live.
So, hello everyone. Thank you all for coming. It's really good to see you here. It's been quite an interesting week trying to organise this event. Things have had to be quite dynamic with COVID-19, but I think we've managed to rustle something together that hopefully we can have a great time over the next few days. So these events we've sort of held in the past are great for bringing together the Nextflow community and actually seeing the application of Nextflow pipelines in sort of a best practice setting, which is essentially what we're trying to do with NF Core. And it tends to work quite well. We do them side by side, and we've got the the core team here, the majority of them. So we've got Phil, guys stand up, the core team. So we've got Phil, Gisela, Maxime, and our honorary core member, Paolo, who is sort of the Nextflow guru. So he's only here for today. So we need to make sure that he goes home very mentally exhausted, essentially. So a little bit about this institute. It's 96 labs. It's quite a big institute. It's only recently built. It's a few years old. The science here is quite varied. We work on clinical samples. We work on things, immunology, malaria, Ebola, all sorts. So it's a really interesting place to work. We're sort of now in a phase where everyone's in the building and we're slowly starting to grow and do more interesting things. Me personally, I work in the bioinformatics core facility here, and there's 14 of us, and we essentially collaborate with labs that want to do some sort of data analysis, the majority of which is sequencing data. And that obviously needs some sort of pipelines and analytical methods in order to do the analysis. And so I started dabbling in Nextflow a few years ago because we'd done an internal benchmark for SnakeMate versus Nextflow and CWL and all of that stuff. And we settled on Nextflow. And I wrote an ATAC-seq pipeline at the time to analyze some data we were having because it was quite an intricate sort of analysis, and I got fed up of having to copy and paste scripts all over the place and try and get things working. And then, out of the blue, Phil turned up at the Crick. He was invited by the head of sequencing, and in a single throwaway comment, he said, "Why don't you add that to NF Core?" Which got my head spinning a little bit. And now I'm organizing dinner for all of you. So dinner is going to be at Dinnerama. It's quite a cool place. It's sort of street food, and you get to pick whatever you want to eat. Amazon have kindly agreed to sponsor the event, and everyone will hopefully want to drink £3,000 between 40 of us, but we've got the drink should be free, and then we'll have sort of £15 food vouchers, and hopefully there'll be an excess left over, so if you need any more, then just come and talk to me. The directions and information and stuff we've got all online on Google Drive. I think, are you going to give pointers as to where that is and stuff? I mean, it's all on the event flyer and everything as well, so it should all be available, and you should be able to find it on the London 20 Slack channel anyway. In terms of staying alive for the next 3 days, we've got a canteen which serves breakfast in the mornings, and then lunch generally from 2 to 2:30. There's a cafe, which some of you have already been to, where you can get snacks, coffee, and other stuff all day. There's hot and cold taps in the communal areas on each floor, and if you want, you can go to one of the restaurants or takeaways in St. Pancras if you want. The only slight complication there is with the security pass. So whenever you leave, you need to make sure that security, make sure security know that you're attending the event, so they'll keep the security pass for you on the side and then just give the same one back to you. So the hope was that everyone that's now coming over the next 3 days will have the same numbered security pass for the 3 days, so security will know exactly what's going on and who's where and stuff. I don't think I need to talk about this because security just did. And if you have any questions, then the way that we've organized things is that I couldn't find a room big enough, essentially, to have us all in one room. So I've booked us in multiple rooms, and there'll be at least one Francis Crick staff in each room, as well as a core member in each room from NF Core. So if you have any questions, first point of call would be to ask them. If not, the London 20 Slack channel. And we're also going to have dedicated channels for whatever your interests are and whatever you decide you want to tackle during the 3 days. So you can also post on there. And if anything, come speak to me. Right, I think that's it. The next bit is going to be after you. Thank you.
Good stuff. Yeah. Nice. All right. Hopefully everyone can see and hear me. Wave at me if you can't. Thank you everyone for coming. It's brilliant to have another hackathon event. A lot of excitement about this one, a lot of buzz. Not just from Harshal, but and I'd like to thank Harshal for putting in a phenomenal amount of work. It's been this has really caught us by surprise, this hackathon. We started off thinking, I think you originally told Crick Security it was going to be 20 people. And when 20 became 30, 30 became 40, and then when we got to 60 and 65, we were like, okay, seriously, we need to stop now. And so it's really kind of taken us by surprise. And then, of course, to throw a spanner in the works, the whole coronavirus stuff coming around the past few weeks has thrown lots of uncertainty in just to make life more difficult. So thank you to those of you who've come, and to everyone who's listening on the live stream. Thank you for joining us, and hopefully this will be a useful event for everybody. So my name is Phil Yules. I work in Sweden, in Stockholm, at the National Genomics Infrastructure, which is kind of like a core lab, but for the whole country. We do large amounts of DNA sequencing, and groups from Sweden come to us, and we basically run their library prep and their sequencing, and then do some limited bioinformatics work for them. So we kind of got into Nextflow for the similar reason as Harshal mentioned. We're processing tens of thousands of samples every year, and we needed something kind of robust and stable to handle that. And through building those pipelines up and getting more and more of them and starting to standardize the best practices, the NF Core community was kind of born semi by accident, mostly with the help of a couple of people who I met at a Nextflow hackathon, Alex Peltzer and Andreas Gillen. And Alex was going to be here, but unfortunately his company in Germany, who he's just started working with, has told him that he can't travel. But he's going to be joining us on Slack. And with the help of those two guys, we started trying to generalize this beyond just the borders of Sweden, and we kind of came up with the NF Core framework. And so right from the start, this has been a really exciting community endeavor, which has involved a lot of people. And that's been something completely new to me, and it's been a lot of fun. Right, I should stop talking and get on with it. So today I'm going to talk a little bit about an introduction to NF Core, what it is, and which I've already started apparently. Then the bulk of what I'm going to talk about this morning will be the tutorial for the NF Core framework. This is partly been done before in Barcelona, if anyone came to the Nextflow meeting last year. It's also available online. So if it's completely not new to you, then I won't be offended if you kind of start typing and start working on stuff. But we figured it would be good to get everyone started at roughly the same point. And so everyone has kind of the same basic knowledge as we start the hackathon. it's also slightly backwards because tomorrow we're going to have another much shorter talk where I'm going to talk about kind of good ways to run the pipelines and kind of set them up. And kind of logically, this should go first, really, because this tutorial is mostly about making your own pipelines. But because it's a hackathon, we're expecting quite a lot of you to be getting on and writing pipelines. We thought, okay, let's start with the creating a pipeline tutorial. So that's where we'll begin. And then at the end of this talk, I will just cover the broad hackathon projects that we've kind of got lined up and talk about what they are and kind of what's involved. If you have any questions, wave. I'll try and keep an eye on the comments, just people waving so far, so that's okay. And shout, and I'll try and do my best to answer. Okay, so NF Core is three things. It's stable pipelines that people can use. So it's kind of a finished product for end users that people can run and just kind of get out of the box best practice analysis for different types of data. And they come with certain features, which we'll go through a bit more, such as kind of configuration, niceties, and helper tools. It's also a framework and a community for developers. So one of the key things that started it off was having a template to write much of the boilerplate code for Nextflow pipelines. And we also have very strict guidelines. So Nextflow is pretty generous in what it allows you to do, but if it's going to be an NF Core pipeline, we have one way to do it, and it's that or nothing. To enforce that, we have lots of automation, continuous integration. So if you see CI, that means continuous integration. It means like automated runners on the web. So doing tests and code linting, so checking the code quality and code style. And then we have helper tools just to kind of get you on your day-to-day work with developing pipelines. But probably the most important part of NF Core is this community, writing documentation for everybody to use, everyone collaborating on the same set of pipelines instead of redeveloping their own version in their own institutes. And that's where the power of NF Core comes. And we coordinate all of this through Slack. We broadcast updates through Twitter and now YouTube. And we have in-person events with hackathons. So the very first thing to do if you want to be involved in NF Core, and I recommend everyone does this for the hackathon, is if you haven't already, go to the NF Core website, hit the join button in the top right and jump onto Slack. You can you need an invite to get into Slack, but you just click a button and you get an invite. Follow Twitter, subscribe to the YouTube channel, and kind of get involved in all these different channels, and then you'll have all the information you need at your fingertips and be able to coordinate with all of us. To give you a snapshot of how this has grown over the years, this is when it started in 2017. And like I say, there was like the three of us, and that was it. 3 different institutes, 3 different members. And a year later, when I gave my first update talk about this at the next Nextflow meeting, we had grown what I thought was extremely rapidly, mainly because Paolo tweeted about us before I really thought we were ready. And lots of people got excited. And so we had already passed 100 contributors, where a contributor is someone who's written an issue or written some code. I gave another talk last year in 2019. We jumped over 700 followers and kind of getting into the Slack, starting to catch up GitHub, so people were involved in chatting, as well as just contributing code and issues and bug reports. And as of a couple of days ago, this is how the community looks in terms of numbers. We have over 1,000 Twitter users, which is phenomenal. Over 30 different institutes have registered, taken the time to add their logo and put themselves on the map, which is a manual process, so that's quite demanding. And I have hundreds of people both on Slack and on GitHub. And this is it's fascinating to make this slide. Every time I give a talk, I have to update it, and it always surprises me. So it's a real pleasure to be involved in this. It's pretty global now. These are the logos of the institutes who have added themselves to our community page. I can't remember when I last updated this, so there might be a couple missing, but these institutes are based all over the world. So to start with, we had a very European-centric focus, as most of us were from kind of the European states, but we're really starting to become more and more global now. I think someone said they were going to join us remotely from India. We've got people in the States tuning in, so we're kind of really spreading across the world, which is great to see. If you look at the website traffic, that maybe gives you a more accurate picture of who's looking at the website and where they're based. And as you can see, pretty much wherever there are people doing high throughput sequencing, especially, there are people kind of looking at the website. This is if you go to the NF Core website, you can see for the manuscript, the reviewers wanted a lot more information about the state of the community and how it was growing and was it stagnating. And so instead of just making a one-off plot, I ended up getting completely carried away and made a big web page with a lot of graphs, which you can view at any time and they update in real time. And so this is a plot of Twitter followers, and you can see a very steep little bump at the end, which is kind of satisfying to see that come in. And that's, of course, because we finally got a publication for NF Core publication just a few weeks ago. So check it out if you haven't already. But yeah, that was huge kudos to many people involved. Right, that's the end of my introduction. I'm going to launch into the tutorial now. And you'll find that basically all of these slides are already on the web. Also, this tutorial, I originally designed this tutorial to have exercises sprinkled through it, but because we're a bit squashed on time and we want to get on with the hackathon today, I've just cut out all the exercises from the slides. So if you'd like to, especially if I'm moving a bit slowly, jump on the website, find this material, you can read through what I'm talking about, and you can find exercises to try this stuff out as I go. And that's, of course, a really good way to get kind of familiarized with what I'm talking about. So generally, the tutorial covers these points. Using the NF Core tools to kind of list and to run pipelines, and then a bit more detail on how to make new pipelines and what the process is involved around that. So, something I start a lot of my tutorials with is a recommendation of a tool, which is called TLDR. It's got nothing to do with Nextflow or NF Core or anything, but I love it. And I think you should all use it, because very often when people ask me questions, I go and use it myself anyway. And it's just a command line script or tool that you run, and it's kind of very, very, very short documentation for different command line tools. So if you run TLDR Docker, it just gives you a bunch of different example commands. If you run TLDR Singularity, a bunch of different example commands. It's open source, so people can write their own, and of course, we've written a Nextflow one, I think. Definitely a Singularity one. A few of them.
Very soon.
Is there not a Nextflow one?
No. There's yours.
Okay, good. But it's really good. So, I mean, the latest version of this is just like a bash script that you stick in your bin directory, and it just works. So go and grab that. It's really helpful. If at any point you run into problems and you need help, then Slack is where to go. I've already just talked about that, and that's a URL where you can go and join. And for those of you who may not be so familiar with Slack, it's basically just a kind of a chat client. And then you can see on the left here, these are the different channels which helped us to organize the conversation. So if you're talking about specific pipeline, every single pipeline has its own channel. So you can talk to people who are involved in that pipeline specifically. There are also pipelines about other parts of the framework, for example, local testing, Singularity, and stuff like that. And this extends beyond today and this week, where most of us are sitting online all the time there. Okay, I'm also going to talk a bit about the helper tools, which are NF Core specific. So it's important to draw a distinction also between Nextflow and NF Core. Nextflow is the workflow runner and, of course, integral to all of this. The NF Core is kind of its own separate project and works in a kind of sphere around Nextflow. And we have our own helper tools, which are nothing to do with Nextflow, really. They just help you use it. They're called NF Core tools. And because the people who wrote these tools, mostly me, are much more familiar with Python than we are with Groovy, we wrote them in Python. And so you can install it through the Python package index or Bioconda. I should change this really. We've had some issues with this. So really you need to set up Bioconda before you try and install it and set up all the different channels. And then you don't need this -c, and then it should work. But you can check their website for documentation on that. There's a bunch of different things that these wrapper tools do. So if you do --help, you can see all these kind of subcommands. So they all start with NF Core something, and then you can run any of these subcommands. There's actually a few more now as well. And hopefully the command line help is relatively useful. And probably the simplest is just NF Core list. And if you're online, it will grab a list of all of the different NF core pipelines which are available. It will also check your local Nextflow folder, which is where Nextflow keeps a copy of your pipelines if you've just run the GitHub URL. And it will tell you if you have downloaded them, and if so, when you last got an update, and whether the version you have is the same as the latest release from the NF core repository. It also tells you the versions and when the last release of that version was, and you can sort by different things. So it's just a quick command line reference to get the same information that you'd get on the web in combination with what you've got locally. Okay, running pipelines. You need Nextflow. Hopefully that's kind of... You've got this far without realizing that, then I'm a bit concerned. Nextflow is pretty much all you need, apart from you need something to manage the software dependencies for each pipeline. Nextflow can do this in a lot of different ways, but all of the NF core nearly all of the NF core pipelines support at least any one of these three. I'll talk a little bit about how this works in the back end shortly, but basically if you have Conda or Singularity or Docker installed, then you should be all right. We strongly recommend just sticking to these two if you have any choice at all. Conda, we got quite a lot of support requests about Conda, and I suspect there's not that many people using it. It's more problematic than the other two, so even if you're familiar with it, try and use these two if you can. Docker is very commonly used on the cloud and stuff like this, but lots of people working on traditional clusters have some difficulties getting it installed, in which case Singularity is kind of a good go-to. Most clusters can have Singularity up and running for you. So check it out if you can. And then really it's just as simple as running Nextflow with the name of the NF core pipeline. Nextflow will handle pretty much everything you need in the back end, sorting out all the software requirements, sorting out all the code for the pipeline, and you can specify also, importantly, which version of the pipeline you want to run. So if you do -latest, it will grab the latest version from the GitHub repository on the master branch, which should be the last release. If you want the cutting edge, bleeding edge development code, which may be unstable, you can choose to use -r and then the dev branch. So -r actually works with any release name or branch name. So you can also do this with specific branch names, with their specific features being developed. But best of all is always to use it with a release number, because this means if you use the exact same command anytime in the future, you're guaranteed to be running exactly the same pipeline code, and the software dependencies are specified within that pipeline code, so you'll be running with exactly the same software components as well. So it's best for reproducibility. You can also run Nextflow pull, which just fetches a copy of the pipeline code without actually running it, and that also works with the -r flag. Every pipeline comes with documentation as one of the requirements for NF core. This is bundled with the pipeline itself, with the pipeline code written as Markdown in the docs directory. But also on the NF core website, you can visit NF core / the name of your pipeline, whatever that is. In this case, it'd be RNA-seq. And then there's a docs tab. So you can view all of this in a nice, kind of slightly nicer format on the NF core website. You can also run --help as you would with any other command line tool, and you should get pipeline specific help about running that. So that's also a really good place to start if you're trying out a new pipeline, because if you get as far as getting the help output, then that's a good thing. If it breaks before you get there, then you have a bit more of an issue. Cool. Right, configs. This is a bit of a beast. I'll go through this in slightly more detail tomorrow. But generally speaking, every pipeline comes with a default config, a base config, which has just kind of got sensible defaults, and it's always loaded as the first step. You then have configuration profiles, which is Nextflow's way of bunching together a bunch of different configuration options and allowing you to specify them all in one go with a single command line flag, which is -profile name. So there's a few of them that come with every single pipeline by default, and they are Docker, Conda, Singularity, and test. So if you just quickly want to run with Docker, you can just do -profile Docker. You can then use what we call institutional configurations. So these are held in a separate repository called nfcore configs, and every pipeline grabs them and updates, so they're immediately available everywhere. So that's a really good way to keep kind of server-specific configs. And then you just need -profile, like the name of your cluster, so -profile.max or -profile.csc. And finally, you can have local files. And all of these configs are loaded sequentially, so they all overwrite the previous one. When you're doing config profiles, note that you can load more than one profile, and just do a comma-separated list, but the order in which you specify them is the order in which they'll load. So if there's any conflicting parameters, they will overwrite one another. The test profile is a little bit special. If you look in the config files for any pipeline in the one that's called test, you'll see that it specifies a bunch of URLs for actual FASTQ data files, or whatever data files if it's not sequencing. And the idea behind this is that you can run any pipeline with this command, basically. You shouldn't need really anything else. And it will download some test data and it will run it for you. These test data sets are super, super tiny. So they should only be like a few megabytes, and it should run very quickly. And this is how we ensure that pipelines don't have kind of basic syntax errors and stuff. So it's also a really good way to test that the pipeline works on your system. As a really good starting point, you can do -profile test, Docker if you're trying to run with Docker. All of the data for this is not stored with the pipeline, because then you'd have to download it every time you downloaded the pipeline. It's all kept in a separate repository called test data sets. And when you run this command, you should see something like this, that the pipeline launches, and then it's kind of running with remote files which are all stored on GitHub. And Nextflow will be automatically downloading them for you if you have an internet connection. Okay, you've tried running with --help. That was fine. You've set up all the configs you need, and when you did run it with a -profile test, it ran successfully through, so you're pretty confident that everything is now set up. So now it's a question of running this pipeline for real, and if you've read the documentation, then you can get started. But of course, every pipeline has its own configuration and own kind of pipeline flags which you'll need to use, so start with reading a documentation. Something that we're hoping to work on more this hackathon is a wrapper tool called nfcore launch. And that will then, the idea behind this tool is it will lead you through all of these options and describe what they are, show you what the default is, and allow you to change it if you want to. So this is a much more kind of user-friendly way of launching your pipelines. This relies in the back end of something called JSON schema, which I'll talk more about at the end. If you're running offline, then obviously Nextflow can't fetch all of the stuff it needs automatically. So then another one of our helper tools comes in, which is called nfcore download. And that fetches basically everything the pipeline needs, sticks it in a directory, and wraps it up for you so that you can transfer it to your secure offline cluster. Then everything will be there and hopefully configured so you can run pretty easily. Okay, that was the first part done. Now on to the fun stuff. Any questions about running pipelines? Good. Only a couple of people asleep. I'm doing well. So, nfcore create is where you start always with a new pipeline. It's a wrapper tool in nfcore, and it runs just a very basic wizard which has a template file, asks you for a few parameters, and then it inserts these parameters through the template wherever they're needed, and sets you up with a basic boilerplate pipeline with all the standardized code that you need. It looks like this, so you kind of put in a name, a description, an author, and then it just runs through and generates this for you. It also importantly sets up the Git repository for you, and it sets up all the different branches and stuff that you're going to need at a later date, which is why it's really important to start with this rather than trying to port an existing pipeline to nfcore later. If you start with the nfcore create pipeline, then your life is just going to be much easier. Once you've done it, it also gives you the commands you need to do to then push your new pipeline to GitHub. And then from there, then you can start writing new code. This template comes with a whole bunch of special comment lines, which are all basically marked to do nfcore. And these you can work through automatically if you have like your code editors often come with like plugins to highlight these to-do comments. So you can kind of, it's a good way to get started with your new pipeline. You just work through all of these comments one at a time. and it tells you what you should do at this point in the pipeline, at this point in the template. So you can work through all of them and start building a new pipeline from there. We also have this code linting tool, and this also recognizes them. So when you try and test your pipeline code styles, it will tell you it found this string on this file. So it's easy to make sure that you've gone through and addressed all of these points in your new pipeline. You need to set up all the software dependencies in your pipeline. Now, I mentioned that we support Conda and Docker and Singularity. And the way that we do this is we always start with a Conda file, a Conda environment file. This builds a Conda environment, which can be used directly for the pipeline, but it also works within a very, very minimal Docker build file. And that Docker build file basically just says it copies in the environment file and then it builds a Conda environment inside the Docker container. So this means you don't actually have to touch the Docker stuff at all. As long as you maintain the Conda environment, everything else works in Docker for free. And then if Docker's working, Singularity works, because Singularity images can be built from Docker images. So this means we only have to maintain a single file with a list of software that's on Conda, or BioConda, along with those versions, and then everything else downstream works automatically for free. And we get to maintain multiple different software packaging environments for the price of one. All of the Docker images we host on Docker Hub, which is a free building and hosting platform for Docker images. And then when you run Singularity, it dynamically pulls the Docker image and builds that into a Singularity image. The environment files look like this. They're very simple for those of you who are less familiar with Conda. We start with a name, which is also generated by the template. We start with the channels set up for use with BioConda project, which you don't need to touch. And then we just list all the different software packages and what version they are. You must pin specific versions. If you don't, then the code linting will fail. And you can also, if you want, specify specific Conda channels before each one, if it helps. So you just go through what you're going to use in your pipeline, and you stick everything in here, and then it should automatically build and work.
You have multiple Conda environments.
So, yeah. This is the thing where I get to the point in the talk and I say, this works most of the time. Nextflow can handle multiple Conda environments. Nextflow can handle a different environment for every single process in your pipeline. Up until now, we've tried to avoid that. Really, back in the early days, we discussed whether it's better to have one environment / container per process or whether to have one for the whole pipeline. And because many people, we were using Singularity containers, we thought it was better just to try and stick to one container per pipeline. It's easier to manage and the total file space used is much smaller. So that's the approach we took, for better or for worse. So where possible, we try to stick everything in one environment if it works. We try and fix it if it doesn't. We try and add missing packages to BioConda where they're not there. And we just try and get it to work that way. If it doesn't, and sometimes it doesn't, then we start to deviate. And if you look in the guidelines, you'll see that the guidelines say you have to have Docker and you should have Conda. And that's for that reason. Because some pipelines have, for example, software which has got licensing issues, which means it can't be on BioConda, so then you can only have this specific Conda Docker package. Some pipelines have software which is Python 2.3 or just completely incompatible in some way, and then you have to split it up. So it happens. But where possible, we try and keep it simple, basically.
Because with Conda, what happened to me is that I had many cross-incompatibility.
Yeah.
So if you try to add two packages at the same time, it would fail.
Yeah.
So I had to create two different environments. It wasn't possible to fix all of the dependencies and stuff like that.
Yeah, and that happens. We've managed to fix a lot of these things ourselves. HiSat2 now has a Python 3 BioConda port, which was already existing, but we fixed it because we noticed it was broken. There's a lot of examples where we've hit problems like that and managed to go in and fix them, which is great for everyone using BioConda as well. So I think that's the best way to go if possible, but yeah, if you can't, then you can't. Sometimes there's no option. It's worth saying that we use Docker Hub to build and to host the packages. So when you push your code to GitHub, when Docker Hub's all set up, it will automatically trigger a new build with a new environment and give you the new software dependencies. But this is pretty slow on Docker Hub. It's a free resource. So if you're developing, it's really good just to build the Docker image locally if you're running with Docker. And you can do that pretty easily. You just change directory into your pipeline directory and do Docker builds kind of current directory. But importantly, because your pipeline specifies the Docker Hub name and tag, so dev being for the dev branch, NF core pipeline, you need to, when you run Docker build, you need to tag it with the same name. Then when you run the pipeline, it will look at what Docker container it needs, and it will see that it has it locally already, so it won't bother trying to grab it from the web. So then you'll be running locally, and this is much, much quicker. Note on Docker Hub, you can't have any punctuation, so it's NF core without a hyphen. Note to anyone else coming up with project names or communities in the future, don't use punctuation. We are NF core with a hyphen most places, we're NF core without a hyphen on Docker Hub and Slack, and we're NF core with an underscore on Twitter. I'm sorry. Right, hands up if you're newish to Git. All right, this is for you guys. No. Most people have used Git a bit. Some people are self-professed Git masters, and most people lie in between. So if you're already super happy with Git, then just treat this as a refresher. But NF core community revolves around Git and GitHub. So it's kind of important that you're very familiar with these concepts. So I'm just going to recap them. Git has commits, which are little packages of code that you've written, and at any point you can branch off into a new branch. Hopefully this is not new to you guys. And then you can continue working along that branch without affecting the previous branch. At some point when you're happy with that new feature or whatever, you can merge that branch back into the original one, and these commit history here will be merged back into that branch. Okay, so we've got branch, merge. You can also take entire Git repositories or GitHub repositories and fork them, which is basically just making a copy under a different name. And in this case, we've got the NF core organization where we've got one repository or one pipeline, and we've forked it to my personal account. You get an exact mirror of that, so you get the same branches and the same commits. I can then carry on developing on my fork without affecting the upstream fork that I came from, so my personal development fork. And when I'm happy, I can do the same thing. I can merge these commits back into the original pipeline as if it was a branch. And these extra commits will be kind of merged into the same commit history. And we do this via a pull request on GitHub. Pull request is not Git, it's GitHub. And it just gives you a web interface, basically, to look over the code which is being proposed, the changes which are being proposed, and gives an interface for reviewing this and commenting on it and discussing it. This is central to the way we work in NF core. So if you want to make a change to an NF core pipeline, you fork it, you make your own personal copy, you do those changes locally, and then you make a pull request. And then we all discuss whether it's a good idea or not, and either reject it, which happens very rarely, or merge it. And this process is often quite back and forth. So it's not just like, here's my code, do you want it or not? Usually there'll be some suggestions. So like, this would be a bit better if you did it like this, or I've noticed a bug here. Every NF core pipeline can have multiple branches, but it needs at least 3. It has master, it has dev, and it has template. The master branch should only ever have stable release code. That is, it should have the commits from the latest release. The reason we do this is that if someone runs nextflow run pipeline name, it just grabs the default branch on GitHub, which is master, and it runs that. And so if we had development level code there, if people weren't specifying the specific release that they wanted to, then they might get development level code, which is not kind of super stable. So the default master branch should only have the stable releases. The template branch is a special case, which you should basically never touch. Right? The NF core create command at the start, that made the template branch for you, and then you just leave it there and forget about it. It branches off from the main repository at the very first commit when you have just used the NF core template and you haven't added anything to it. And what this is used for is, because the template is not a static set of files, we're constantly adapting and improving and developing it. It means that when we make a new release of a template, we can go back and we can automatically make a pull request against this branch, because this branch has just the vanilla version of the template. And so the changes to the template are compared, and then we can make a pull request from that branch back into your developed pipeline. And in theory, it very cleanly brings across just the things that we've changed in the unmodified template code. In practice, it's sometimes a bit messy and you have to fix merge conflicts, but it mostly seems to work quite well, as long as we keep the updates fairly small. So you always need a template branch, and it should be relatively untouched. It shouldn't have any of your developmental work on it. Finally, you have the dev branch, which is where you keep the latest version of the development code as you push towards the next release. Something we've decided quite recently in the NF core team is that the pipeline should have dev as the default branch before the first release. So this means when there isn't any stable release code, if you just run nextflow run, you'll get the dev branch instead, which is most likely to be semi-functioning code, hopefully. After the first release, then we switch the default branch back to master. Okay? Hopefully everyone's still with me. Remember that pull requests, when you make them with proposing a change, must always be against the dev branch. Pipelines that have releases, the master branch is a default, so when you create a new pipeline, it will try and make it against the master branch. We don't want your developmental code there, we want it on the dev branch. And we actually have a test to check this, and as of a few days ago, I think it gives you a nice little comment saying, oh, it looks like you've done this wrong. But basically, we won't merge it if you make it against master. So make sure you make it against the dev branch. Remember to always update the changelog about what it is that you've done, so when people get a new version of the pipeline, they can see what's changed. And remember that these pull requests need to be reviewed by someone else. If you're merging to the dev branch, it needs to be approved by one other person. It can be anyone in this room, it can be any NF core member. And if you're going from a new release, then you need to have at least 2 different approval. By this way, we hope to ensure that the call for code quality is signed off on, basically. Try and make sure that the person reviewing your code is in a different place, if possible, a different institute, not just like the guy sat next to you. Okay, to make life easier, we have some automated testing. It's almost impossible to manually review every single line of code that comes in. We're at hundreds of thousands of lines of code. So to just kind of make this possible, we automate everything we possibly can. So probably one of the most important wrapper tools, aside from the creation wizard, is the lint command. I need to update these slides because I changed this format a couple of days ago. But anyway, it basically still looks the same. You run nf core lint, you give it the directory of your pipeline on your computer, and it runs through a whole bunch of different tests which we've manually written. You can see the progress as it runs, and it tells you if you have any errors. If they're bad errors, it just stops straight away. But hopefully they're all good. And then at the end, you get a nice summary saying how many tests passed, and then whether you had any warnings and failures. Warnings are okay, they can be merged. If there's any failures, then the pull request will be automatically get a little red cross, and we won't merge it. In fact, it's impossible to merge it unless you're administrator. Each one of these tests has a specific ID, number. So when you look at them, you will see that they all come with this URL. And you can just click on this URL in your browser, it will open a web page, and hopefully give you a bit more description about what went wrong. In this case, we used to use a variable called params.container. We changed this in the template, and so there's a test to make sure that you've updated your pipeline. And if you haven't, if we still find this old version, then we trigger a failure. So you just go in, update it, and then rerun, and everything's fine. These tests run automatically every time you push code to GitHub on your fork or on the NF core fork. And they also run every time you make a pull request. So you can run it locally just for quicker iterative development, but they also run automatically. And then this is what the web page looks like. So if you follow that URL, you should see a slightly more detailed and kind of readable description of what it is that went wrong and why it's a problem and how to fix it. Okay, test data. So I said already how this works, but of course, if you're making a new pipeline, you also need to make some new test data, which can actually be more tricky than it sounds. The way that we do this is kind of slightly different Git magic. If we stuck all the test data for all the different pipelines on the same branch of the test data sets repository, then that repository branch would get really big, so downloading it would be slow. So instead, we keep the main default master branch just with some instructions and nothing else, and then each pipeline has its own branch. And then this means you can do what's called a shallow clone of the branch of the repository you want, and it fetches just that test data for just that pipeline, which is much quicker. So the first thing to do is to go to this repository and make a new branch named the same thing as your pipeline. Then comes the tricky bit. You have to find the smallest possible test data set for your pipeline, which still works. And I mean really, really, really small. If you can, often just having like the human reference genome in there, it's not going to work. It's too big. So if you can run with yeast or with Phi-X or a single human chromosome or part of a single human chromosome, then that is the way to go. You also need to find the minimum amount of test data which will actually succeed in your pipeline. So if you can get away with 1,000 reads, then that's great. We want to keep this as light as possible so it runs as fast as possible. Once you've got this set up, then you can make the test config. There's one that comes with a template, so you just basically fill that out and change it, put your new URLs in where you've uploaded it to the test datasets repository, and make sure that this works. Then this will run automatically every time you do this continuous integration test. Until fairly recently, this is one of the places I had to update the slides. Oh, I've got a question. Can Git flow be used for creating new branches and features? Yes, you can use, so Git flow is a way of kind of handling different types of branches and workflow through branches, and you can do whatever you want on your own fork, as you correctly say, of course. So if you have a preferred way of working with Git and GitHub, then you can do that on your own fork. As long as it ends up with a pull request to a dev branch, we're quite happy. And we do also have other branches within the NF core fork, so if there's multiple people working on a specific new feature which is not ready to be merged into the dev branch, then we do that kind of semi-Git flow. Yeah, okay. With all the continuous integration and automatic testing stuff, we used to do this with a free service called Travis CI. You may have also heard of Circle CI, but quite recently, basically this year, we have switched to the new kid on the block, which is called GitHub Actions, which has only just been released, actually. We got early beta access to it, but it's now fully released. And GitHub Actions is basically continuous integration automation service built into GitHub itself, which is also free and also has a bit more power and a lot more flexibility than Travis. We particularly like it because we spend a lot of time creating new repositories, new pipelines, and before, every single time one of the admin team would have to go in and set up Travis, which is kind of a hassle. But with GitHub Actions, it just automatically happens. You fork the repository and the actions are there and they run straight away. It looks like this. So here, Maxime, I think, Alex has made a pull request on the NF Core Sarac pipeline. You can see along the tabs here, if you've made a pull request on GitHub before, it should look familiar. You've got the code changes, on the pull request, you've got the conversation about it, you've got the code changes, but you have an extra tab here with GitHub Actions called checks. And then down the left-hand side, you can see each of these different GitHub Actions workflows, they're called, confusingly. And then within each one of those workflows, you have a bunch of different steps here. So you can see here down on the NF Core workflow that it's running the NF Core lint test, and you can see the same output I showed you before, but now this is running on the GitHub server automatically. And importantly, the exit code of this process is being monitored, and here we've got a little green tick, which means it exited successfully, and all of these ticks will be propagated back onto the conversation page of the pull request, and if any of these fail, we get a little cross, and the GitHub merge is blocked. So it helps to highlight potential problems with the code. Make sense? Cool. Right. You've made your pipeline. You've done your test data. You've spent weeks on it. It's perfect. It's your baby. And it's ready to go. The crowning moment in every pipeline developer's career is, of course, releasing their pipeline, probably for the first time initially. And NF Core kind of has its own organically grown set of guidelines around how we do this in a good way. There's actually specific documentation on the website about adding a new pipeline, which takes you step by step through all the different things you need to do in more detail than I'm covering here, and probably a little bit easier to read. But the first thing you should do, really actually before you run the template or anything, is come and talk on Slack about what it is you're proposing to make. One of the key guidelines within NF Core is we should only have one pipeline per data type, or that we shouldn't have any pipelines which overlap in their functionality too much. So if you come as a user, you've never really seen NF Core before, and you say, I want to do some bulk RNA-seq analysis, you find the RNA-seq pipeline and it does what you want. And you don't find 15 different RNA pipelines which all do sort of the same thing but a bit differently. So it's really important that you come and discuss your idea first with the community and kind of you get feedback about whether it's a good idea or whether it's too big or too small, or So the first thing to do is come and talk about it. We have a Slack channel dedicated to this. You have to join the NF Core organization. This is pretty easy. You just go and ask to be joined, post in Slack or on a particular issue thread. You can find this on the NF Core join page, and one of the core team will add you, and then that gives you immediate write access to all NF Core repositories. And then you can, when you've kind of got a sign off on this, you can fork your pipeline, which you've been developing on your own personal account. You can fork that to the NF Core organization, and it becomes an NF Core pipeline. That's not the end of it. You have to set up Docker Hub. So we have this automatic building of the Docker images, and something I haven't touched on at all yet is Zenodo, which is a tool for giving DOIs, digital object identifiers. So the same, how we have a DOI for every academic paper, you can have DOIs for anything, and we have DOIs for every pipeline and every release of every pipeline. Zenodo does this for us for free, and it also has GitHub integration. So once we set it up the first time, every time you make a new pipeline release, you'll get a free specific DOI, as well as having a generic DOI for the whole pipeline. So we have to set those up. That's usually set up by one of the core team. So then you've got everything set up on the NF Core organization, all working, but you still don't have any releases there. So the first thing you need to do is make sure that all of the tests are passing. If you have any little red crosses, then you need to fix them before going any further. And then we do what we call like a community review or a pseudo pull request. Now, what this means is we make like a fake pull request on the NF Core repository, and we make it against the very first commit. So the very first commit is when you use the template. And so by making a pull request against that, we have a web page which shows all of the changes you've ever done on your repository, which is basically the whole pipeline, minus a few boilerplate codes which you've never touched. This is obviously a huge pull request. We're never going to merge it or do anything with it, but it gives us a place where we can have a community review of what you've written. And then you need a couple of people to go through all of the code you've written and check it over, and preferably try and run it as well. Again, it's super good if someone can try and run it from outside your institution, because the whole key point of NF Core pipelines is they should be as transferable and portable as possible. So if someone else manages to run it on a totally different system in a different country, then that's a really good indicator that your code is indeed portable, because sometimes there can be hidden things you haven't really thought about or accidentally let slip through. These pull requests can be short. They're usually pretty long. Hands up if you've done this. Hands up if it was painful. It's sometimes a bit painful because there can be a lot of feedback, but you've got to treat that as a good thing. This is the community aspect of the whole project, and this is how we get the confidence in the quality of the pipelines which are on NF Core. So you get to benefit from the experience of all the people in the NF Core community. Right, so that gets signed off. So then we only have to do that once ever, just for the very first release. After that, we only bother checking just for new things for that new release. So once you've got the kind of sign off, then you can make a pull request from your development branch to the master branch. And again, then that gets signed off, test pass, slightly different tests run when you do this. So it's important to let the tests finish. And then we create a release or tag on GitHub. When you create that release, a bunch of stuff happens automatically. The website updates to show the release, which in turn means anyone running NF Core lint on the command line will get updated information. There's an automatic tweet sent out to the Twitter account saying this pipeline's got a new release. There's a new Zenodo DOI made. There's a Docker Hub image is tagged with the name of that release. Anything else? Quite a lot of stuff happens. So it's kind of a fairly critical point when you're developing your pipelines. But basically, that's the end. Once you've done that, then you can go back. There's one more thing to do, which I don't think I have on the slides, which is you make a new pull request back to dev, and you just bump the version number to the next version .dev, so that then everyone can continue developing changes for the next release. That's it. So on that note, we have a version number for every pipeline. And we try and stick roughly to what's called semantic versioning, which basically means that the first number should be major changes. So if you go from version 1 to version 2, it's because what you've done completely breaks everything. So it's not backwards compatible. So that's a major release. You have minor releases, which is what we do most of the time, where we add a bunch of stuff, then it's kind of moves the pipeline along, it's extra functionality, and that's classed as a minor release. And then the final one is if you do a release and then someone's like, oh, I just tried your new release and it broke, and you're like, ah, and this happens also inevitable for kind of software development sometimes. So sometimes then we need to do a patch fix, and that goes on at the end. The NF Core pipelines have this version written in a surprisingly large number of places. And we used to just manually update it each time, and we got it wrong a lot of times. And if you have a mismatch of these version numbers in the Docker and the Conda environment and in the pipeline code, then it can kind of cause a lot of problems. So first we added lint check to make sure that they all match up, but then we added an actual command where we say bump the version. Here's my directory, I want the version to be this now. And this tool will run the lint checks, and then it goes through and updates the version number everywhere for you. It's much safer to use this. Note that the pipelines also specify what is the minimum version of Nextflow that you should use to run the pipeline. So you can do ---- Nextflow to bump this version as well. Okay, I mentioned this in passing before. I think we're nearly at the end of the tutorial. I'm doing well. When we do a new release of a tools repository, which is the one that contains the NF Core pipeline template, then we do this automatic synchronization process where we have a bunch of stuff set up on GitHub Actions, which looks at what's changed, and then it makes a copy of every single pipeline, and it checks out the template branch of every single pipeline, and it makes a new commit with a new version of a template using the same variables that you used the very first time you ran the template builder. Then, once it's made that commit on the template branch automatically using this bot account, it automatically creates a pull request on your repository going from the template branch into dev. So you see from template into dev. In this case, this release changed, added 64 lines and deleted 375. So these are triggered automatically, which is kind of a terrifying process, because when we run launch on tools, it like triggers like 30-something pull requests like that. But it should tell you what's happened, which release it is and everything. And if you look on files changed, then you'll see all the things that have been updated in the template. Hopefully it's all simple, you agree with it all, it looks sensible, and you just click merge. Worst case scenario, sometimes you have to go in and have a bit more of an involved process to fix these merge conflicts. But there's very new documentation on the NF Core website which walks you through step by step how to do this. So you can just kind of check that out. And actually this comment is a bit nicer now, it tells you where to find help. Cool. That's the end of the tutorial. Any questions? Everyone ready to go off and make pipelines and tinker with pipelines and release pipelines, merge pull requests? Happy days. Right, okay, final bit then. Just quickly talk through the different hackathon projects that we've got lined up for you. These are not mandatory. So this is very much up to you about which of these you kind of go into. If you go into any, you're completely free to kind of do whatever you want while you're here doing a hackathon. But if you're looking for ideas, this is a place to start, basically. And this is hopefully a way to also group people together so that people who are working on similar types of problems can kind of sit together and help each other. All of these projects, we have a GitHub project, which you can find here, which is called, if you go to NF Core on GitHub and click projects, you'll find one called London 2020. And this has a loose collection of all the different projects I'm going to talk about with a collection of issues and things to do there. Don't feel put off if there's stuff missing from there, you can add stuff. That's totally fine, but it's a good way to track who's working on what. And if you can, try and follow kind of GitHub best practices for working with this. So if there's an issue that you're going to work on, you can assign yourself. And your picture will appear, and everyone else knows that that's basically been claimed, or that they can come and talk to you about it. If you'll want to work on an issue and it's not on the project board, add it to the project board, assign yourself. Okay? These are the projects then, 6 different projects. We'll start very general and kind of gets a bit more specific. New pipelines. I'm working on the assumption that some people in this room at least will have come to the hackathon with an idea of a pipeline that they want to build, and they're using the hackathon as an opportunity to sit down with a bunch of other people who know about Nextflow and NF Core and to write a new pipeline from scratch. That's great. Remember to tell us about it first, and then especially if you're kind of newish to Nextflow and NF Core, go and dig into all the documentation and work through it and familiarize yourself with it. And then just get stuck in and shout if you need help. That was easy. Existing pipelines, pretty much the same thing, except you don't have a new pipeline that you want to do yourself from scratch. But there's already loads of NF Core pipelines out there and loads of stuff that needs doing. So you can kind of have a look around, especially if you've used a pipeline or you've got one pipeline that you're more familiar with. Go and check out the list of issues. GitHub issues is how we track bug reports and feature requests, and see if there's anything that catches your eye that you think you can work on. Stick it on the GitHub project boards, assign yourself to it. There's a lot of pull requests open at the moment, especially because we did a release of tools not that long ago. It would be fantastic if we could get through some of those this week and get them merged. I imagine also many of you will be creating new pull requests as you do new work. So please try and spend some time looking at other people's pull requests, because otherwise what will happen is next week the core team will look in dismay at 150 open pull requests and then they'll just sit there because it's just too much work for a small group of people to do. So please try and take on some reviewing. Don't be intimidated. You're all part of the NF Core community. You can all review pull requests and you can all merge pull requests. So please do that. If you're working on a specific pipeline, check out the Slack channel, talk, let people know what you're doing, ask for feedback, ask for help. Yeah, discuss it there. Okay, NF Core has got all these helper tools and wrapper tools and things around it. Same thing applies. If you're kind of like maybe writing a bit of Python code, bit of website stuff, you like automation, check out these different repositories which are not pipelines and see if there's anything you can do. There's a bunch of open issues ready to be worked on, and stuff like documentation is really important, especially if you're new to NF Core and Nextflow and you're trying to write something and you kind of figure something out which wasn't obvious to you. Go and write it up in a documentation file. It's all written in Markdown. It should be easy to find and to edit, and hopefully let the future you and the next person who runs into this, like, give them a bit of help. So if the more documentation we can get written this week, the better. That'd be really good. We have Slack channels for the tools repository and the website repository, which are probably the two main ones which are likely to be worked on this week. Modules. Right. The elephant in the room that I haven't mentioned at all yet. Nextflow has two different syntaxes, DSL1 and DSL2. DSL2 came out how many weeks ago, Paolo? A month ago?
No, it's nearly 1 year. No, yeah, 1 year.
Yeah, but it's stable release.
Not yet. Not yet, because we are discussing about this thing.
Yeah. So
very important for me to collect your real needs to close this.
Yeah.
I want to feedback.
So DSL2 lets you do a lot of cool stuff. Probably the most important thing is it lets you write code in other files and pull them in dynamically and share and reuse code between different pipelines. This is obviously super important to the Nextflow community and to NF Core. Everything we have written so far is all in the old DSL1, which is fine, and it's going to carry on working, and we can keep making new pipelines using that. But there's a lot of people want to move to DSL2, and we should also move in that same direction. So to do that, we have made a new repository called Modules, and the idea behind this is we want to make kind of a library of tool wrappers in Nextflow, which can then be imported by different NF Core pipelines or any pipelines. Everything's fine. We're back. If you look into the modules repository, you'll see this is still very, very up for grabs, but this is what we have so far. As you'll see a folder called tools, and then you'll see a bunch of different tool names, and then under here you'll see a script, and this is where the process wrapper code is written. You have a meta file which describes the tool, what it does, where to find it, and also describes all the different parameters which can be passed to this imported process. So all the different things which need to be, and this is going to be used for automation further down the line. And then we also want to have automated tests set up for each individual tool. At the moment, when you make a new pipeline, you run a test which just runs the whole pipeline and just checks it exits successfully, which is kind of crude. So we would like to have per process specific tests. And ideally, we would like those tests to actually check the output of the tool. And then we'll have a lot more confidence in the pipelines and that there haven't been breaking changes. So each one has a subfolder called test with a little mini workflow to run the test and a config. This is roughly what a wrapper looks like, just kind of a process. This needs more work. And this is roughly what the meta file looks like. So you can see at the bottom we've got the different inputs specified here as a list. The test script should then just import that process, and it needs to use test data, which again we're going to store on NF Core test data sets on a modules branch this time, and then ideally we'll validate outputs. None of this has really been written yet, so it'd be great to actually get some hands on this week. And Paolo, I think, is interested. There's a lot of people interested in working in this, so it'd be great if we could make a dent in this, but it's a bit more for experienced people because we need to make decisions about what the best practices should be. Oh yeah, in the last couple of days, so there's been a long-running discussion about how we should manage modules. We now have 2 different pull requests which are both proof of concept, but the idea is that we certainly want to at least have this kind of command in the end where you just do NF Core modules and store a name and it will grab those files for you and kind of manage the versions and everything. And we have a draft pull request as of yesterday, which does this now. And we could also potentially do this using Ponder and some other back-end ideas. So again, this needs more discussion and more development work. So, like with the other Hackathon projects, there's a Slack channel, so please go and discuss. There's lots of new tool wrappers to be built, so kind of taking processes which we already have in existing pipelines and moving them, building them into new tool wrappers in the modules repository. And then, of course, we also need to be great to move all the generic boilerplate code out of pipelines and into a central location, so we only have to maintain them in one place. And the hope is that the template synchronization mechanism will become largely redundant over time. Yeah.
We have a question from the online.
From anyone. But we already doing that. Just explain now.
Yeah. So the question is how to handle modules if one tool has multiple different ways you can run it. So for example, Salmon can index a reference genome and it can also align or pseudo align. So we decided that basically when you import Salmon, you'll import all of those different functionalities. And then you can just use whichever of the process names that you want to use, basically. And so we want to keep it on the tool name specific version. So if you import SAM tools, and then you can use whichever of those SAM tools commands you want to use, for example. Does that answer your question? Okay. Right, AWS tests. So I've mentioned how so far we already have automated tests using GitHub Actions, which use these very, very tiny test data sets so that they run in under 10 minutes with 6 gigs of RAM, or whatever it is that the requirements are. And it's great, but it is unrealistic. Like, we know it's unrealistic. Like, this is not real data that we're running on, or it's not representative for what it will be like when people actually run these pipelines with real life data. So AWS have been very kind and given us money or credits. And the intention with this project then is we set up a very similar infrastructure which runs automated tests, probably only for releases to begin with. We'll see how the money goes. But we want to do it with kind of real life data. So like actual full sequencing runs on actual relevant species. And this will be good to check that the pipeline actually runs, A, on the cloud, B, with real life test data sets. And also means we can host these results after it's finished and we can preview them on the website. So if someone new comes along and says, oh, this pipeline sounds cool, but what does it actually produce? You can just browse through the output files, look at the reports and see whether it's kind of appropriate for what you want. Also down the line, we can potentially compare these outputs and do actual automated testing. So we've got $10,000, which we need to spend before the end of this year. I can't work out if I'm worried that we're not going to spend it or that we're going to spend it too quickly. It'll be one of the two. But it'd be great to make a start on this. Probably much of the initial work we need to do with this won't actually touch AWS. The first thing is to just find appropriate test data sets for each pipeline. It needs to be the right data type, basically, and the right number of samples and the right sequencing depth or whatever. So finding data and planning this is kind of step one. We have a Google Docs file you can find where we can add all this and kind of talk through it. And then we also need to set up all the infrastructure to actually decide how to run on AWS. And then once we've done it manually, work out how to automatically run this through probably GitHub Actions. And there's a Slack channel. It's called mega tests, but that doesn't mean that we want to run massive test data sets. It's just we want to run the minimum realistic size. JSON schema. This has been in the works for quite a long time and hasn't had much activity, but I would love to get it bump started and working. The idea behind this is whenever you run an Xflow pipeline, you can do minus whatever, and it becomes a parameter, params. And then this can be also set as a default in a config file, and you can use it in the pipeline. Hopefully that's familiar to many people. So the idea behind this is that each pipeline will have a new file called parameters.settings.json, which uses JSON schema to describe each of these parameters that the pipeline uses in one place. JSON schema is this really well-defined kind of thing developed mostly for web stuff, but it is very appropriate for us. And it has kind of a bunch of standardized fields that we can use to describe each of these parameters. Importantly, stuff like type. So we can actually say this should be a number. These files are pretty easy to read by UI. It's just a JSON file. And of course, computers like them because it's JSON. They have a nice fixed format. This is roughly what it looks like. So you can say for this parameter, it's called minus foo. We can add the documentation about how it works here. We can say what the default value is, and then in this case we say it's a string, but we're only allowed to pick these two values. And by defining all this stuff for each pipeline, then we can automate a whole load of stuff. We can automate the minus help output. We can check that all the different parameters are described in the documentation and nothing's missing from the actual handwritten markdown documentation. And we can also start to build user interfaces to make it easier to launch pipelines, both on the command line and on the web. Did I miss a slide there? Sorry. I feel like I missed something. I went past it again. Anyway, the other thing we can do is we can validate inputs. So if you run minus resume instead of minus resume, or minus name, or make a spelling mistake when you use your parameter, then we should hopefully be able to capture that. And also, of course, if you specify a number instead of a string or vice versa, then we should be able to capture these and actually validate the inputs on the fly so that the pipeline doesn't run with the wrong input silently. We already have a command line tool. It's called nfcore launch, and it walks you through each of the parameters, and it shows you this stuff in a nice interface. It shows you what the default is, and then allows you to change it if you want. But we've changed our minds about how parameters should work, JSON schema should work. So this needs fixing, actually. So there's a bunch of different things to be done here. Firstly, the wrapper stuff needs to be updated and written and fixed. And there's a bunch of issues that walk through the different steps that need to be done here. And then once that's kind of up and running, then we can go out and build these schema for all the different pipelines. And this will massively improve the usability of the pipelines. So this is kind of, this project, probably more than any of the others, has got a very well-defined series of steps that need to be done. So if you're not sure what to work on, this is quite a nice defined route to work on. Right. That's it. Go forth and hack. Use Slack. All of the communication about the hackathon will be on the London 20 channel. Badger anyone that's got a little core team badge, or just anyone. And many thanks to everyone who's been involved. The core team looks like this. Both Alex and Olga were hoping to be here, but both of them couldn't make it because of the virus, so they're hopefully joining us remotely. Yeah, Harshal, Maxime, and myself are here. But come and grab us, and Gisela, sorry, our newest core member. And yeah, any questions?
This might be addressed in the coming minutes, but where is the best place to hack in this building?
So I hope you're up for playing musical chairs, because that's what we've got planned now.
carry on in the same presentation?
Yeah.
What else?
Right, so for those of you that came in late, I'd prefer not to get into trouble with security, so it'd be great if your security pass, you can just keep it with you and visible at all times. After we've arranged the groups, hopefully I'll be sending them some information to just ease their nerves about having 40 or 50 people wandering around the building. If and when you need to leave the building, I will speak to security again. Then if you can let them know that you're attending the hackathon and that you need to keep the same pass, ideally we're going to have the same pass over the entire 3 days, just to make things simpler. And they should know what you're talking about, hopefully. Right, so we did send out a survey, but only half of you filled it in. So we've got an idea as to what people would like to work on, but I think what we're going to do now is attempt to create these groups a bit more dynamically, just to mix things up a little bit. Sorry. And as Phil just mentioned, there's 6 topics up for grabs. If you're participating remotely, then join the Slack channel. This is also being streamed on YouTube, and we've also set up a Jitsi video conference call link where you can join in. And what I'll be doing is hooking up, so every room will have a monitor. I'll hook up a laptop to those monitors and set up Jitsi there, so anyone that is participating remotely will be able to basically hook into any room that we're working in. And the remote event flyer is at that URL there. So this is where things get slightly tricky. I've managed to book multiple rooms in the Institute, and we need to attempt to create working groups based on interests. You will be most likely in the same room over the course of the 3 days. If you're not, then you will have information as to which one you're going to be in. I just need to find the Google document for me a second. Right, so every room or every group will have at least one Crick member and at least one core member. So if we can get you guys at the back to come forward a bit, then we can use the rows at the back to attempt to organize people. And anyone from the Crick and anyone from the core team, if you can just align yourselves against a row there somewhere.
Which or should we?
So just do alternate rows.
Okay.
Yeah. So one quick person, one core member next to each other against a row, essentially. Right, so I guess we should start with, are there any of you that plan to work together during this event and want to work together during the event? If you could stand up maybe. And go in the same row as Chelsea? Any of you want to work with existing core members that are here on pipelines they may have written? So, for example, Sarek for Maxime. You can go in that row with him.
Any existing pipeline?
Yeah, so Sarek for Maxime, Gisella's B-Cell Magic. I've written the ATAC chipsy.
For ideas for new pipelines, one should discuss the existing ones as well. Or
Sorry, I didn't understand.
if you want to work on a new pipeline, then maybe we should also check with existing ones if that's something that can be added to an existing one or not.
Yes. So that I think all of the existing anyone. So that was my next question: existing pipelines, and then try and organise a group based on that. Is that what you meant?
Yeah.
Okay. Right, new pipeline development. Anyone? New pipelines? Okay, if you can go in the same row as Chelsea.
Including those who want to follow tutorial as well?
Yeah. AWS. If you can go in the same row as Phil. Okay, so take another row. I'm going to be in Chelsea's. Chelsea's a placeholder for me. Existing NF Core pipeline development. Anyone? Yeah. If you can go into the same row as Gisela. DSL2. Okay. Chelsea, how many do we have in our row? I think it's the biggest group there. 10. Okay, so if you can go into Chelsea's, we might need 2 rows for our group because it's the biggest group. I am.
Oh, okay.
Yeah. Right, so we might need 2 rows for our group because it's the biggest room. And who's left? Wei, what would you like to work on? Everyone here do pipelines? Yeah. You're in that row as well. Okay. And so maybe we need to move rows down a bit. So this is the AWS. Sorry, we clearly haven't, so you might have to bear with us. Yes. Anyone interested in Jason? Okay, so can we have DSL2 go with Phil then?
Yeah. DSL2 modules.
That's fine, that's perfect. This is Gisella's group. So anyone who
How do you get out of the way?
So okay, so can you guys come and join this group, Gisella's group? Are you guys in Gisella's group? Okay, so one of you will need to go with Maxine. I'll be in that group, and then we also need someone with Phil from the group. Do you want to go with Phil? And Angus? Yeah. Do you mind going with Gisella? Yeah. And Wade as well, or Gisella? That's fine, that's fine. As long as we can organise people into groups. And Paolo, you're with Phil's group, right? Okay, I think we've sort of sorted it. Let me come down. But that's 10, so that room can only hold 10 anyway, so that will fit that. We've got 14, right, in ours? And how many is this group, sorry? Three. Plus 4. Okay, so you can maybe merge into the bigger group. How many in your group? 3, 6, 9. So one of you can go into Phil's group. 10. Yeah, so one of you can go into Phil's group. One of you can go into Maxine's group, and that will just mean that we've got 3 more. Yeah. So if we organise people like this for now,
because to be honest, it might be nice if there's quite nice if it's in the mark.
Yeah. I think it will be trying to squeeze it around. Or we just keep to this for now, and then I can come around and assess it later on and move people around. I think that'd be easier. Yeah. Okay, so Gisella, who's in your group? I need to do this as security now. So.
Yeah.
Angus.